Hello ninjas, welcome back to my channel. We're going to blink this LED using freeRTOS concept. Let's do this. Okay ninjas, so this is the appearance of the code, and in case freeRTOS was a bit challenging for you to learn, you are at the right place to understand each and every concept you need in a freeRTOS. Okay then, we got 3 steps to consider. The first one is to configure GPIO pin, and then we're going to create the task that will be blinking the LED. And the third part, and it's a final one, is to use the freeRTOS built-in function, which we're going to execute the task we have created. But first of all, we need to define some of the constant parameters we'll be using throughout the program, which at the very first is to define the pin or the GPIO pin to where the LED will be blinking. For this case, I'll be using a built-in LED, so I can call it a pin underscore LED. You can call it whatever you want, maybe LED underscore pin, whatever. So I'll choose pin number 2, and then I'll come to this step, which is to configure the GPIO. Okay, in ESP32, the GPIO configuration has the certain function for its configuration, which goes as GPIO underscore set direction. And for this case, I'll set the pin LED to be an output mode. So to set it to be an output mode, say GPIO underscore mode underscore output. Then we have successfully configured the pin. So this predefined function, GPIO set direction, has a function or has a purpose of setting an LED pin, which for this case is pin underscore LED, referencing to pin number 2, to a certain mode, and for this case is output. So in case we want to set it to be an input, well, we're going to edit this part here to be input, but for now we need to set to be an output. Okay, then let's continue to the second step, which is to create a function whose task is to blink an LED. So there are 2 to 3 conditions to be considered when creating this task, or we can say the function that perform a blinking task. The first of all, the function must have no return type, so we will be using a void keyword. I'll call it blink LED. You may call the function whatever you want, but inside this parenthesis, the argument should be of a pointer type. Call it arg, simple like that. You can call it whatever you want again. So this is the way the task need to be appeared, and inside the task you need to have a while forever loop, because inside the main, when we come to pin the function or the task to the predefined function of a freeRTOS, there will be no while loop, so the loop will be inside your function. For this case, I'll create a loop while true will be just blinking an LED. So to set the state of an LED, whether to be high or low, there is a predefined function inside an ESP32, which is GPIO underscore set. For this case is the level. So inside this function, you define the pin that you need to set its level, which we have stated so far, which is pin LED. And initially we need to set it to be low, so it will begin with a low, and then we need to provide a delay. In freeRTOS, there is a predefined function called vTaskDelay. So one thing you need to consider that in this function, the number of ticks are those that are being counted as a delay. So if I say 100, I mean there will be 100 ticks delay until this function return to be executed once again. So in case you need to convert these ticks into milliseconds, there is another function called pdms underscore to underscore ticks, this function performs that task I mentioned so far, which is to convert the ticks into milliseconds. So for this case, our LED will remain off for 100 milliseconds. Put semicolon here. I'm going to repeat the same statement, but for this case, I'll set the state of an LED or the level to be high. So this task will first shut an LED off and then switch an LED on. The two tasks will be, the two switching operation will be differentiated by 100 milliseconds each one. So we have completely created the task that was to blink an LED. Now we'll be jumping to the third step. Okay, in this third step, we will be pin the task we have created of blinking an LED into a freeRTOS predefined function. There are technically two functions. The first one is xTaskCreate pin to core, and another one is kind of this one, but is only called xTaskCreate. In this function, you specify the core to where the task will be embedded to. So the core ID is defined by the user. You can say the programmer, yes, the programmer. But for this one, the function itself select the available core to where the task will be binded to. The function selects available core to pin the task, and this function has 7 parameters to pass. This one has only 6 parameters to pass. We'll go one after another. Let's begin with the first one, which is we are in charge to select the core to where we're going to bind our task. For this case, let's comment this one. Okay, in this task, as I said, it has 7 parameters. The first parameter is the definition of the function or the function signature. For this case, is a blink LED. So this function we're going to pin here. Okay, blink LED. This is the first parameter, the task that you need to be executed. The second one is the name of the task, blinking an LED. See, this is the second parameter. And the third one is the stack size. The stack size you can approximate yourself depending on the size of the task you have created. For this simple task, let's give it a 1 kilobyte. Simply we can write that number. And the fourth task, the fourth parameter is the parameter to be passed to the task. For this case, we didn't pass any parameter. So because we didn't pass any parameter, here we can put the word now. It's the keyword now to indicate there are no parameters so far to be passed into our function. And after that, we're going to define the priority level. The priority level in freeRTOS, in freeRTOS alongside the ESP32, if you did not define the highest priority level, by default is up to priority number 24. So I'll take a random number there. Let's put number 10. This will be a priority level. Because there is a single task, there is no need to worry about the priority level. Okay, after putting the priority level, the next parameter is a handle of the task. So what is the function of a task handle? In case you have several tasks and you need to perform, maybe to suspend a certain task when another task is switched. In order to do so, you need to have a handle of that particular task. We're going to talk much more about task handles and task operation soon in the future videos. So stay tuned in my channel. We will cover everything, you know. So for this case, we'll just pass now. Okay, so the final parameter to pass is the core ID to where the task will be binded to. Originally, ESP32 has 2 cores of core ID 0 and 1. So it is up to you to pick one and to put the task into. So for this case, I'll go with the core 1. Okay, I can put comments in front of this for clarity. The first one is the task. The second one is the task name. The third one is the stack size. Okay, the fourth one was parameter to a task. The fifth one is the priority level of a task. Sixth one was about the task handle, which is a very important aspect. And the final one, the core ID. So this is the X task created pinned to core. You create a certain task and you pin to a particular core of a ESP32. So let's come and take a look at this function here, which is X task create. As I said, they are both similar, but they differ in terms of parameters. And for this case, it's just a single parameter. I'll copy this and paste them right here. So in this function, there is only a single parameter that will not be included, which is the core ID. Why? Because this function automatically picks the available core and pins the particular task we have passed it to it into that specified core it has picked. So that's the difference existing between these two functions. I'm going to comment this one because I want to use the first one. After doing so, we need to build and run our program. So we can simply go to the terminal and say idf.py flash monitor. Okay, so the code has been executed completely. As you can see, our LED is blinking as we expected. If you like this video, don't forget to leave a like, and if you like content like this, be sure to hit the subscribe button. Until next time.